What's up, y'all? Today we're talking about interpreting graphs and writing situations from that graph. I just got an email from Melanie asking me if I can explain that. So Melanie, here's my interpretation. The first thing you have to know is that whenever you're talking about interpreting a graph, you're talking about two things. Remember, you have an X and a Y, so you're talking about two things. And those two things could be anything. It could be time and money, time and distance. It all is going to depend on the situation, okay? All right, so that's the first thing. Now, you have to know how to interpret parts of your graph. Here's the first thing. Sometimes we know that a graph may go upward, okay? If the graph is going upward, remember that whatever two things you're talking about, they're both increasing. So I'm going to put both increasing. Okay? Sometimes you'll have a part of a graph that may look like this. Okay? If the graph looks like that, remember we're talking about those two things that you're looking at. Remember that while one thing is increasing, one of the things is remaining the same. So here's what I'm going to put. One is increasing, and the other remains the same. Okay? Then lastly, you may have a part of a graph that looks like this. Whatever two things you're talking about, one is increasing, the other is decreasing. Don't let it fool you. You would think that from here, everything is decreasing, but that's not true, okay? So one is increasing, while the other is decreasing. So to recap, we're talking about interpreting graphs, Melanie. If you're looking at the graph, if the graph is going up or part of the graph is going up, both things are increasing, whatever two things you're talking about. If the graph is a horizontal line, one is increasing, one is staying the same. If the graph is going downward, one is increasing, one is decreasing. Don't let this fool you. Both are not decreasing, okay? All right, so that's the first thing. Now, here's an example of what you may see in your Algebra 1 class, a graph that looks like this. And a teacher may say, hey, I need you to write a situation based on this graph, okay? First thing you want to do, tear it apart. So if I'm tearing apart my graph, I know that this section here is increasing, okay? Which means that whatever two things I'm talking about, both are increasing. This section here, horizontal line. So I know that while one is increasing, something is staying the same, okay? And then this particular part here, decreasing. So while one of my things is decreasing, one is increasing, okay? Got that part? Now, here's what you do. Think of a situation that applies to yourself, okay? You think of a situation that applies to yourself, it's easier to determine the two things that you're going to talk about. Here's a situation that I'm going to use. Doesn't mean that you have to use it, Melanie, but you can if you want to, okay? We know that this is the x-axis, right? Here's the y-axis. Anything that's independent will go on the x-axis. Anything that's dependent will go on the y-axis. Here's what I want to compare. Let's say this graph is comparing time and the temperature of an oven. I'm going to put time down here, and then I'm going to have to shorthand temp of an oven. Now, before I put numbers here, let me think about what I want this to interpret. Okay, I got it. So, I like to cook. My favorite dish is mac and cheese. Let's say I'm cooking macaroni and cheese for Sunday dinner or something like that, okay? For anybody who likes to cook, you know that if you're going to make mac and cheese, the first thing you have to do is to warm up the oven, okay? So I'm going to turn the oven on. The temperature for mac and cheese has to be 375 degrees set, okay? So let's say I'm starting here. This is my initial temperature. I need to get to 300 375 degrees. Now think about it. What's happening with an oven when you turn it on? The temperature is slowly increasing until you get to your desired temperature. Over time, it's increasing until you get to your desired temperature. You with me on that? Okay, so I made my mac and cheese, put the milk in it, got my shredded cheese, all that. The macaroni is done. Bam, it's in the pot. I'm ready to put it in the oven. And my oven's at 375 degrees. So during this time, my mac and cheese is cooking. Over time, as time goes on, the mac and cheese is cooking at 375 degrees, so my temperature remains the same. Now, for all those cooks, how long does it take to cook macaroni and cheese? If it's in the box, maybe 5 minutes, but this mac and cheese, it's gonna take maybe 2 hours if you do it right. I like it crispy. So let's say I put 2 hours down here. Now, what's happening? After 2 hours, my mac and cheese is done. I'm taking it out of the oven and I'm turning my oven off, okay? When I turn my oven off, what happens to the temperature? The temperature slowly decreases back to 0, okay? So now if I had to add numbers for what I do, how long does it take for an oven to warm up? I would say maybe 5 minutes, 5 to 10 minutes. Now I know I put 2 hours over here, but I can just easily change that to 120 minutes if I want to be consistent. And if I wanted to put temperatures down here, I can make this 175, 275. And here's how you interpret your graph. So again, what have you learned? Know the parts of your graph, know what the line increasing means, staying the same, going back down, and then determine what relationship you want to use, Melanie. Everything can be different, but this one will work all the time.